The first major problem we have to solve in this project is to shuffle a deck of cards. Fortunately, even after simple shuffles, the probability that this deck of cards and this deck of cards is in the exact same order is astronomically improbable. The number is 1 in 52 factorial, which is an insane number, and it is likely that this shuffle has never been dealt or shuffled by anyone on Earth, and the same as this. For this project, I think the best way we're going to do it is to split the deck in two and have cards going in on top of each other in a more orderly fashion, so they're in one pile in the middle, and somehow we're going to be able to randomize how they fall in and in what order, and you'll be able to take them out and put them in as many times as you want to shuffle them as many times as possible. The next big challenge is dealing cards around a table. Depending on how many players are playing in each game, we need to deal the number of cards that are needed for the specific game that we're playing reliably. We don't want cards hitting the middle, getting confused. Each time we need it to hit a player's hand with some discard cards.
I spent the time between 7:30 and 8:30 making a majority of the important design decisions. The key to the success of the system relied on being able to control the movement of individual cards. I took inspiration from a money counter that used rubber bearings to pass single notes through the system. Using Lego tires to control the cards seemed like it might work, as I had the right amount of friction to grab a single card. "3D printing is dead time, so I needed to get printing ASAP. So at 8:30 I started the 3D modeling by creating attachments between the servo and the tires and making sure the fitting between a stepper motor and a 3D printed part fits perfectly. Servo motors, like these micro SG90s, are typically non-continuous motors, which means they can only rotate about 180 degrees in one direction and then have to move in the reverse direction, back 180 degrees. This doesn't work for our project, as we need the cards to be shot off in the same continuous direction, so there is a trick where you can easily change the servos to be continuous. To make SG90 servos continuous, you simply have to open up the case and snip off the end of the axle that connects to the limiter. And if there is a little node on one of the cogs, you'll need to cut that off too. Also, to give you a better control of the direction and speed, you may also need to glue the potentiometer still at about 90-degree angle from the motor. At 9:30, I had a card feeder concept of design using a modified servo, Lego tire attachment, and a cardboard box. The test showed real promise, but exposed the first mistake, which should have been super obvious. I designed the connection to the Lego tires as the same as a Lego model, expecting it to be a fixed joint that would rotate the wheel, but they're not designed like that at all. In reality, the Lego will spin around the joint axis. So I need to go back and make a joint that will be fixed. Looking at the Lego joints, I was able to leverage the cross-hatch design in the real rim to make it fit perfectly.
The stepper motor has been flipped from the original design so that the wires will circulate with the system as it spins around. This, at the moment, is going to spin on ball bearings. I don't have ball bearings, but I have marbles. Moving up, this is the feed outlet system that will shoot the cards out to the player. They will be shuffled into this space through these two external feeders. These external feeders will be our servo Lego wheel design that will just shoot the cards in. They'll be at different heights, so that'll feed in lower, that'll feed in slightly higher, so that when they come in at the same time, they don't collide and fold up or fold down. Up the top will be all our electricals, Arduino, maybe an LCD screen, a potentiometer. The potentiometer is going to set how many players are playing. So if there's 4 players, it'll divide 360 by 4 and spit out a card every 90 degrees. And then if there's 5, it increases and decreases if there's less players. So that's how we know how many players will be playing. That'll be passed into the Arduino, and then that'll sort everything out. I've now got to go model it. So let's see how we go. It's 10:02. I think we're going okay. Okay, 12:30 p.m. update. The first print is printing, which is printing that. I've got to then go on to the next bit, which will be feeding the cards down and getting the cards all in from the side. That's going to take 2 hours and 35 minutes, which means we'll be done at about 3, which means I've got about 3 hours to get the next bit done and keep thinking about everything else. All right, 3:30 p.m. update. Second bit printing that. This has some problems. I did this too low. Sometimes the cards go off sideways and hit those edges. So I need to put parts in there and fix that so it guides it in between that gap. Okay, it's 8 p.m. I had to go to indoor soccer, and whilst I was there, this print failed. That's supposed to be there. I don't know how that happened, but it might be a glue job. It's so disappointing. It is now 9 p.m. 9 p.m. The third print is printing. I've had to move rooms and cover it in blankets so my family can sleep and we can print through the night. While that's printing, I'm going to go get the electricals all done, try and get that sorted, modify a couple of things that I just overlooked and got completely wrong, and change things that just were terrible design decisions. So we'll see how we go. It is 11:35 p.m. We got this. It's printed so far. I've just spent about an hour carving bits away from it so it all fits. The printer's still printing over there. I'm starting to wire up all the servos, write the Arduino code, get everything ready to start doing the electrics, and then once that's done in about an hour and a half, so at 1 a.m, I can just chuck that on top, put the base model and the electronics holder on the printer, get that printing. That'll hopefully be about 3 to 4 hours. I'll have a sleep and then get up and put it all together, and hopefully be done by 7 a.m. within the 24 hours. It is 12:37 a.m. I'm pretty sure I'm delusional at this point. I have this. It's probably one of the worst things I've ever made in CAD. It's supposed to spin on these marble ball bearings using a tiny stepper motor which shuffles the cards into there using servos that will just fall onto the cards powered by an Arduino and a servo board. It sounds absolutely ridiculous when I say it out loud. And the probability of it working is so extremely low. But it's something. Just want to show you where we're finishing off the day / night. It's 1:30, Tuesday, 1st of July. And this is what we're working with. So the idea is that there'll be cards here, like so. There's a lever system, which is one of these. That'll sit in there and rest a servo with a tire on there and just spin these one by one into there. That'll spin on a base, which is being printed. That'll be done at 5:15 a.m. So I've set my alarm for 5. I'll be up. I'll get that off the printer, put it all together, get all the Arduino wired up, get all the servos wired up, get the power to it, get them all in their place, with rubber bands or wire or whatever and just see if it works. I'll have an hour and 45 minutes in the morning to get everything done, and whatever I have at 7 is what I have at 7. There's a little fail in the print, and it's 5 a.m. I'm looking at the prints that I just had off the printer from last night, or when I was sleeping. This has come off the bed and curled up at some point, which is a bit annoying. I might have to saw that edge off. This works well though, my little ball bearing, except just as I was going to sleep, I remembered that I changed the stepper motor from going up into the machine to going down into the base, and I completely forgot about it, and now it goes up into the machine and not down into the base. Also, I forgot to consider the wire, the path of the wire for this, which was something that I also needed to consider for the base, but it was about midnight when I was designing it. So now we're just stuck with this, and I'm not too sure how I'm gonna fix it. I've got an hour and 18 minutes left to get everything sorted. But that's a positive. ChatGPT is making my code. The last print is printing. I've got 17 minutes now to get it all done. Wiring's done. Prototype is down there. Everything that needed changing has been changed. I think we might actually be in a spot where the hardware and software of this project is done before 24 hours, which is crazy to think about. It's 7 o'clock, which means the challenge is now over. I've given myself the ability to put it together later, like make sure all the joints are better, wire it all in, get all the servos on, run the code, because as long as I don't make anything new, I feel like that's fair enough. So I've got to sort all this out, but right now I'm going to go back to bed so I can actually put it all together without losing my mind. Alright, I've wired everything up, put it all together. It's just connected with like metal wires and rubber bands and stuff. But basically the system works by setting the number of players with this potentiometer. So that says the number of players. I don't know if you can see, 5 players. Down to 1 player. The cards will fit here and here. And once they're all there, you can press the black button in here, and that'll deal them all in, shuffle them all in to down there. The LCD screen will say
shuffling, press the button again to stop. And when you're ready to deal, if the stepper motor was plugged in, the stepper motor would move to the relevant position of how many players were playing. But for now, we're just doing one player. So you press the red button, the servo down the bottom will move, and then a system in there will spit out a card. It'll only spit out 2 cards per person. So it'll stop after that. It'll say down here, dealing to player 1. And now it's just going to be waiting for a new instruction. I don't know if it shuffled them, but they got in. They definitely got down there. And moving into the dealing section, we got the cards that sit here, and then we've got our first servo, which just moves the cards from their resting place into this 2-wheel system, which pinches them, and then will hopefully shoot them out through the feeding. Oh. It's trying to. It's like really trying to. It's time to test the stepper motor. I've disconnected this from the dealing spit because when it spins, all the wires get jumbled up and it doesn't spin, because I just completely forgot to consider that. So I've set the potentiometer to 4 players. So someone's playing there, someone's playing there, someone's playing there, someone's playing there. So deal 2 cards to each person around the whole thing. So if we press deal, it'll come up with dealing there. We'll deal the first player. Nothing comes out because it doesn't work. And then it moves from player 1 to player 2. Deals them a card. Tries to. And then it'll move to player 3. Deal them a card. And then it will move to player 4. Maybe this will deal 1, or 2, or 3, or 4, or 5. And then it will move back to player 1. It's like so close to working. Just the cards need to feed into the feeder a bit better. The cards need to not hit things on the dealer. The software works, the potentiometer works, LCD screen works. This works. I cut that off because it didn't print properly and it gets stuck on there sometimes. Everything's just one day too short of being designed, I think. But let me know what improvements I can do. I think I just need to clean up everything and it might actually work. I'm still trying to figure out how to get these to like get shot and move the whole length of a table, because there's no point of having an automatic dealer if you have to grab your own cards from the automatic dealer. So once all those things are sorted, maybe I'll get around to it. Otherwise, for one day, I'm pretty happy with how this project went. We've actually got a product that does things, doesn't do what we want them to do, but it does things. And maybe one day it will do things. So I hope you enjoyed. Thank you for watching.